today we're going to start talking about multiplying matrices. And you'll see that when it comes to matrices, adding and subtracting and multiplying, they take on different form than what we've seen with numbers. I know adding is a little bit more straightforward, and so is subtracting. Multiplying, though, is quite different. It's a different process. Not challenging, just different. So what was the requirement to be able to add or subtract matrices? When they need to have identical dimensions. 3 by 4, 3 by 4, 5 by 7, 5 by 7. Now, to multiply a matrix A by a matrix B, okay, the situation has to be a little different. So the requirement is the number of columns of A must be equal to the number of rows of B. So columns of one, rows of the other. The best way to figure that out, all right, so you don't have to remember rows and columns, is this. Suppose you're multiplying A times B, right? You write it in that order, A first, then B. You put down the dimensions of A, suppose it's 3 by 2. You put down the dimensions of B, suppose it's 2 by 4. Now you must write it in that exact order. So if it's AB, A first, then B. Now, once you have your dimensions here, you have to look at these inside numbers, the inner numbers. So 3 by 2, the inner number is a 2. 2 by 4, the inner number is a 2. Those numbers have to be identical. They have to be equal. That means you can multiply. Okay? So since these are the same, you can multiply.
You can multiply them?
The matrices. All right? So that's how you know if you can multiply the matrices. The dimensions of the inside numbers have to be the same. Okay. The inside numbers of the dimensions have to be the same. Once you've established that, yes, you can multiply these two matrices, now we think about, okay, the product, once you multiply it, the finished product, what dimensions will that have? For that, we go to the outside numbers. It's 3 by 4. Those are the dimensions of AB. Okay? So we'll do examples right now. So going back here, the product AB will have the same number of rows of A and columns of B. But this is really how we do it. So let's go down here. Okay? Let's go down here. We're not multiplying this. We just have to see whether it's possible to multiply them, and then we have to figure out the dimensions of the product. So what are the dimensions of the first one here? Dimensions of the first one?
3 by 2.
3 by 2. Liel, what are the dimensions of the second one?
2 by 4.
2 by 4, all right? Yes. So look, you see that these inside numbers are the same, right? So you can multiply. And now the other question is, yes. And now the other question is, once you multiply, what dimension is the product going to have?
3 times 4.
3 by 4. Okay, so once you multiply it, the product is going to have 3 rows, 4 columns. Okay, that's what it's going to look like. Okay, 3 rows, 4 columns. Okay, take a look at this. Take a look at this next one. What are the dimensions of the first one?
2 by 3.
2 by 3, and the second?
2 by 2.
2 by 2.
You can't do it.
Can't multiply. These are not the same, can't multiply.
So it's like no solution?
Yeah, you just say not possible, or, okay? Okay, one thing. With numbers, if I do 3 times 5, is that the same as 5 times 3?
Yes.
Yes?
Yes.
Yes.
So the answer is just the product. I mean, the thing, right?
We haven't really done anything yet. We're just getting used to what we're doing.
Oh,
So with numbers, you could do 3 times 5 or 5 times 3 and you get the same answer. With matrices, A times B is not the same as B times A. All right, you can't go backwards. So if it asks you to multiply A times B and you switch the order, don't get the right answer. All right?
So it's not like regular multiplication.
It's not like regular multiplication at all. Well, why? Look at this first one. This is a 3 by 2 times a 2 by 4, right? Now suppose you switch the order, right? When you switch the order, you will have 2 by 4 first, then a 3 by 2. That can't even multiply. So they're not even the same. Okay? All right. Okay, so now we're going to start multiplying matrices. And I have this one page to just do this one problem, but it's not going to take us that long every single time. I just guide you through the process, all right? So here's what we're going to do. Suppose you have A and B. Let's talk about dimensions and see what the product is going to be. So what is this? This is a 2 by 3 and a 3 by 2. And so the product will be 2 by 2. Right. So when you multiply, your matrix will look like that. So do you see how, first of all, when we were adding, it was a 3 by 3, a 3 by 3, and you get a 3 by 3. It was a 2 by 3 and a 2 by 3, and you got a 2 by 3. Here, look at how different these matrices look, and then look at how different the product looks, right? So they have nothing to do with each other. Okay, now what you're going to do is we're going to start filling in this matrix. How many numbers do we have to generate? 4. 4 of them. You go in order. You can go in whatever order you want. But you know what? The most logical thing to do is to start with that first number, right? Okay. That's how you do it. So you tell yourself, all right, I'm going to start with this first element of matrix AB, right? So this is matrix AB. So we're going to start with the first element in matrix AB. What position is that? Row what? Row, this red one. What position? This red one?
Row 2.
Row 1. And?
1 by 1.
This is row 1, column 1, right?
Yeah.
Okay, so we're looking at row 1, column 1. Because we have to generate the value for row 1, column 1. In our matrices, we take row 1, column 1. Okay? In our matrices, we take row 1, column 1. Why? Because the answer is going to go in row 1, column 1. Are we all okay with this?
Yeah.
Okay. Now, what you're going to do. In row 1, how many numbers are there? 3. In column 1, how many numbers are there? 3. So what you have to do, that's not a coincidence. It's always got to be that way. In this row and in this column, you always have to have the same number of numbers. So what you're going to do now, watch me here. You have to match the first with the first, the second with the second, and so on. So what's the first number here in row 1?
2.
2. What's the first number in column 1?
3.
Okay, so you multiply those two together. So, right, so you get 2 times -3. Now, plus the second number, -3 times 5. I'm just writing them down for now. Plus the third number, 1 times 6. Okay, so look up here for a minute and see how I do it. It's this plus this plus this. All right, so just go down. So do you see why now the dimensions like have to match up? Because then you run out of numbers to match with each other. Okay, so that's it for the first space. Okay, now I'm going to go and I'm going to fill in. We're moving on. Now I'm going to fill in this one. What position is that? What row is that red one?
1.
Row 1, column 2. So I take row 1 with column 2, right? And I'm going to match 2 times -4, the first with the first. The first with the first. Plus the second, -3 times 1. Plus the last with the last. Okay? Now I'm going to move on to the next space here. What position is that? Row what?
Row 2, column 1.
Row 2, column 1. So this time I take row 2 and column 1. All right? And again, I match the first number with the first number. The second number with the second number. The third number with the third number. Okay? And now, the last one, what position is this?
Row 2, column 2.
Row 2, column 2. So we take row 2, column 2. So it'll be 5 times negative 4 plus 0 times 1 plus negative 2 times negative 2. All right? And finally, we're going to multiply all this in order to get our product. Yeah, multiply, right. So basically simplify. So negative 6, look at what we have here. Negative 6 minus 15 plus 6, so that's negative 15. The second one is negative 8 minus 3 minus 2, negative 13. The last one, the second row is negative 15 plus 0 minus 12 is negative 27. Finally, the last one, negative 20 plus 4, negative 16. All right, so that's your AB. That's very, very cool and very, very fun. So two things, hang on, before you start. Yeah, two things though. You really, when you're doing this, you have to just be unplugged. Because if you're on, you know, Twitter and Snapchat and like you're texting and you're FaceTiming and doing all that and still trying to, there's like no way, okay? And you just have to be careful. Just have to be careful. If you get too confident and you're going too fast, then you always miss something. So just, you know, take your time. We're not going to show this much work for every single one. This was just the, you know, the trial one to guide you guys through it. Okay, question. GH. So let's figure out dimensions for G. 2 by 3 and 3 by 2. And it's going to, okay, so it's very important to write it here. So write this first. 2, 3, negative 2, negative 8, 1, 7. So it's going to be a 2 by 2. And I like to put in my slots. Okay? So now, here's how I do it. All right? This position is row 1, column 1. So I take row 1, column 1. Don't be afraid to use some visual aids here, right? So now it's 1 times 2, 3 times negative 2, negative 5 times 1. Okay. Moving over, this is row 1, column 2. So I erase this one. I'm going to do row 1, column 2. So 1 times 3, 3 times negative 8, negative 5 times 7. Later, you don't have to write even this much. Okay, next, let me...
So it goes like row 1, column 1, row 2, column...
Yeah, so listen, you could go out of order. You know what? Okay, I'm going to be a rebel, and I'm just going to do this one next. Okay? What position is that? That green one. In this matrix, what position is that?
Row 2, column 2.
Row 2, column 2. So I take row 2, column 2. Okay? So 4 times 3 plus negative 2 times negative 8 plus 0. I love the zeros. Okay? And then this one, what position is this in the black?
2, column 1.
Row 2, column 1. So I take row 2, column 1. So 4 times 2, let's minimize the writing, that's 8, plus negative 2 times negative 2 is 4, plus 0 times 1 is 0. So finally, what do I have? 2 minus 6 minus 5, negative 9, right?
Yeah.
Next to it, we have 3 minus 24 minus 35. So 24 and 35, those are the two negatives. 24 and negative 5 is 59. 3 minus 59, negative, it's 3 minus 59,
56.
negative 56. Here I have 12. And for the green one, I have 12 plus 16, 28. And that's AB. No, it's GH. Okay?
That's pretty easy.
Mm-hmm.
It's not that bad. It just,
You wrote A.
I'm scared I'm gonna get like one thing wrong and it'll.
Yeah, that's what happens. Okay, so next we're going to do HG. So let's write down HG. So 2, 3, negative 2, negative 8, 1, 7. So look, we did GH, then we did HG. If these were numbers and we did 5 times 3 and 3 times 5, we'd get the same answer. But not for matrices.
So then you would
We're
get
doing
the-
H times G. So I write H first, then G.
You would get
The thing is like 3 by 3. Oh, I'm on a different problem.
So here, this is a 3 by 2 and a 2 by 3. Yes, I can multiply, and the result will be a 3 by 3.
Do we just need to know that to know like kind of what the result is?
Yeah. Yeah, so you could start filling them in. So, you know what? I'm going to be a rebel again. And I'm just going to pick a random one. Okay? Give me a random one to do first in that matrix of 9 entries.
Wait, I have a quick question.
Yeah.
Since it's 3 by 2 and 2 by 3, you multiply the inner ones or the.
You don't multiply anything. So if the inner ones are the same, then you are allowed to multiply them. Right? And then the outer ones give you the dimensions of the product. Okay, so look, I'm going to be a rebel. I'm going to do this one first. What position is that? Row what?
row 2, column 3.
Row 2, column 3, right? So I take row 2, column 3. How many numbers are in each?
2.
2 and 2. You see how they have to match up? Okay, so now that'll be negative 2 times negative 5 plus negative 8 times 0. All right, so you see how like you don't even have to go in order. But my OCD doesn't like not going in order, so we're going to keep going in order, okay? I was just doing that to show you guys a point, okay? All right, this first one here, row what?
Row 1.
Row 1, column 1. Keep saying that to yourself and, you know, take row 1, column 1. So now, the first times the first, 2 times 1 is 2, plus 3 times 1 is 3. Okay? Oh, 4. Oh my, thank you.
No.
Yikes. See?
12.
Okay. Next one here is row 1, column 2. So 2 times 3 is 6. 3 times negative 2 is negative 6. Next one, row 1, column 3. 2 times negative 5 is negative 10. Yeah, minus or plus 0. Okay, so go ahead and do the second row. You already have one done for you. Go ahead and do the second row.
Negative 30. It would be negative. Yeah, it would be negative 30 because 8 is negative.
So go ahead and do the last row.
Oh,
Okay.
All right. We hopefully all got this.
Yeah.
So when we put it all together, HG will equal 2 plus 12, 14,
0,
0,
negative 10,
uh-huh,
negative 34,
mm-hmm.
10, 10,
Was that a 10? Yes. Next one.
29,
Okay.
negative 11, negative 5.
Awesome.
Yeah.
Okay, so take a look. Take a look. This was GH. Look at how that looks. And this is HG. So another one, just to hit that point that
Very different.
when you're multiplying matrices, they're not commutative. You can't go backwards. All right? Okay. So why don't we do DE? Here. What are the dimensions of D?
2
2
by
by
3.
3 and then 2 by 3, but you can't do it.
Get out.
And this one is 2 by 3, so not
Oh,
possible.
if it's the same thing, you can't do it?
Well, not that if it's the same thing, you can't do it.
The
You
middle
can't do it if these middle numbers were not the
Were
same.
middle ones and the other ones?
Yeah.
That was the condition to multiply, right? Because look at what happens. Look at what happens. If I'm doing row 1 and column 1, look, I don't have the same number to match them up with, right? You can't match 3 players against 2 players. That's ridiculous, right? You can't, all right? So that's why it doesn't work. So not possible. That was a quick one. All right? Okay. So here, this is going to be a little bit of a review from what we did before, okay? So we have to do J times K plus L, okay? J times K plus L. So what are we going to do first?
K plus L.
K plus L, that goes first. So let's do K plus L. So K plus L, we're experts at that now. What do we get? Okay, so here's what we do. Hang on. Here's what we do. It's a 2 by 2 and a 2 by 2. They have to have identical dimensions. You just add corresponding numbers. That's it. So 3 plus negative 4 is negative 1, and then 1, and then 2, and 3.
I like rewrite it so it doesn't fit with
Yeah, that's best.
that times J.
So now it's that, no, it's J times that. So now J times K plus L, J is going to be 2, 4, negative 5, negative 2, times K plus L. Okay? What are the dimensions of the first one?
2 and 2.
2 by 2 and
2 and 2.
2 by 2.
So the first
You can obviously multiply, and then you're going to get a 2 by 2.
should we do it?
Yes, let's do it. So row 1, column 1. All right, I'm going to race you to it. I love these. All right, so hopefully this is what you got. All right. Okay, once you're done with that one, I want you to, as independent practice, move on and do this next one. I'll answer questions in just a second. I want you to move on and do this one. Now look at what you're doing here. You're doing J times K. You're going to do that first. you're going to do J times L separately, and then you're going to add them. All right? Okay, go to it. When we are done and finished with this, what did we get for the answer?
8, 14, 1, and negative 11.
Oh my.
Did we get
It's
8?
six. What did you get? 8.
6, 14, negative 1, negative 11.
I multiplied
Now,
that. So
okay, now, does that answer look familiar? Have we seen that
Yeah,
before?
the negative 11, I feel like I saw.
Where?
up here.
Up here. Look, look. We saw it up there. The whole matrix, we saw it up there. Well, why? Are these two related? J, K plus L? J, K plus, are they related?
Yeah.
How? Okay, so I have J times K plus L. Can you, if I multiply these in, what do I get? JK plus JL.
Oh, it's just like
Is that what we did here? That's what we did here. All right, so just to show you that the distributive property works for matrices.
if we know. Okay, so if we get like a
Now, yesterday we had our first introduction of representing pieces of information that are related in matrix form. We're going to do that and a little bit more today. All right, and we're going to see how you can manipulate one or more matrices to figure out something relevant, right? Okay, so you own 3 car rental locations and offer 3 choices for vehicles at each location. A sedan costs $80 a day. Okay, a minivan $100 a day, and an SUV $125. The chart below shows the number of each type of vehicle available at each location. So in your, first location in the valley, you have 7 sedans, 5 minivans, 2 SUVs. You have another location in the city, you have 6 sedans, this many minivans, and that many SUVs, and then you have a third location somewhere that we don't know, okay? So, Arcadia. You only have 4 sedans in Arcadia and no SUVs because nobody goes there. Okay, write a matrix V for the number of each type of vehicle at each location. That's this, okay? So your matrix V is gonna come from this. So in the first location, you have 7, 5, and 2. Second location, 6, 8, 6, 4, 3, 0. So to remind you, this is the sedan, the minivan, and the SUV. And then these are your locations, A, B, C, right? By the way, you don't have to write those labels on the side. I'm just writing you to show you something, okay? Then it says to write a cost matrix C. Now the cost matrix C, right? How are the costs given to you? You have a sedan for $80. You have a minivan for $100. And then an SUV for $125. So what do these represent again? A sedan, a minivan, and an SUV. Okay, so those are the matrices. So on an actual, like if you were doing it and you wanted to give answers, you would just do the matrices without these labels. Why am I doing the labels? Because suppose, okay, how many columns in the red one? One column. What are the dimensions of the red one? 1 by 3, and this is a 3 by 3. I'm sorry, this is not a 1 by 3. What is this? Liel, what are the dimensions here?
It's 1 by 1.
3 by 1.
Oh, 3 by 1.
3 rows, 1 column. So now look, if I were to do first row, okay? If I were to do first row, first column, look at what I have. Sedan, sedan, minivan, minivan, SUV, SUV. Do you see how they match up? That's not a coincidence, okay? So that's the reason we write it that way. Now, suppose you wanted to figure out if on a magical day you were able to rent out all of your cars, how much money would you get, all right, from each location? You would have to multiply them, all right? So the total daily income, you have to multiply them. So we're